which must go under that sleeper. The measuring canister for chips has a slot near the top. When 10-inch sleepers are being packed, the canister is filled with chips up to the slot. When 12-inch sleepers are being packed, the canister is filled to the brim. The boxing of heavy ballast between the sleepers is now opened out where the figures show that it is necessary. Where there is a continuous run, only alternate beds are opened. After this, the line is jacked up with the jack on the outside of the line for safety. Then the necessary number of canisters of chips is spread evenly under each sleeper for 15 inches on either side of the rail. It will be remembered that the figures read off from the sighting boards and the void meters represent units of canisters of chips. Each canister full, when spread under a sleeper for 15 inches on either side of the rail, is equal to 1/16 of an inch of slack. For this film, a newly packed sleeper was removed and revealed a perfect bed of chips for 15 inches on either side of the rail. All that remains to be done after every sleeper has been packed is to backfill the boxing. A test taken with a void meter while a train passed over a newly packed sleeper revealed no slack at all. On curves, sighting boards are used on the low rail. Then the high rail must be adjusted to the static measurements on the low rail. The step board for checking cant is graded in steps of 1/8 of an inch. For too little cant, add twice the number of steps to the number of canisters of chips to go under the high rail sleepers. For too much cant, deduct twice the number of steps from the canister figure. If the excess of cant figure is greater than the figure on the low rail, the high rail must be lowered by the difference. If, however, excess cant persists all along the curve, the differences may be added throughout the low rail. After finding cant figures for the high rail, void meters must be used on hanging sleepers. Measured packing has undergone extensive tests of the LMS and is being generally adopted. Attention to the details of the process will give a packing as nearly perfect as it can be.